It appears to be live-ish. Making a video. Yeah, it's not live, doesn't make much difference. It appears to. Right, that's working, so I think we've done with that. And we'll do some comments first, just as context, and I guess we have to deal with this crap, which is sort of annoying because I've sort of been over this stuff. People just keep making assertions and they don't back it up with anything called evidence. All right. I'll just read as context since I'm here with the John Gray comment. But at university, they teach us that electrons, when it moves, it induces a magnetic field. So again, I pointed out, it has nothing to do with the electron moving. It has to do with the electron changing its position relative to the protons in an atom. The electron doesn't induce a magnetic field. And I pointed out how that is. Anyway, with north and south, is the electron still a monopole? It clearly is the monopole of magnetism. You want to make a magnet, you put an electron here and you put a proton here. And then you make a bunch of those. And that's how you make a magnet. So yes. So you get an argument about that when it just seems that logic is indestructible. Frankly, you can't rationally escape that statement. Atoms make magnets when the electron and the proton are not in a balanced condition. Anyway. And so his new comment is just more of the same. Anyway, so it says this guy complaining about the video I did on the Wallace Thornhill guy or whatever he is, the Electric Universe, and he says, religion, hardly. 30 seconds in is all I need to hear from you. Right, so I play Thornhill's video. I play his statements. I'm quoting him directly as you can. And these pussies can't take it. They can't even listen to the video where the evidence is presented. I mean, it's just so weak. Ugh. I mean, I didn't put the words in his mouth. He said them. Okay. And this idiot, Smrag, whatever, something or other. So he's this ugly, bald guy. I don't even think that's unfair. I mean, he's not very attractive and prematurely bald. Aren't you one of the founding fathers of quantum mechanics, Professor Doctor? So that doesn't, you can't even get one or the other, asshole. Junkie cocaine shithead. So we know that, you know, using heroin does cause premature balding. So you're a heroin addict, obviously. Well, anyway, he's a fan of Sin Car. He upvoted some boring video by the guy at Yale who I've played, botching the single slit and double slit experiment. Who's a nice enough guy, but again, it's just, they're supposed to be professors. You think, you know, they would give a shit about at least being thorough and complete and accurate when they're going to describe fundamental experiments of quantum mechanics. He called it the fundamental experiment, the most important experiment, and yet he can't explain it correctly. I mean, this is sort of bullshit, right? That reeks of bullshit. So yeah, so I was going to do that, but now I can't play that because I have to do this other thing where I have to explain again how reality works when it comes to pressure in the universe. So we'll make another effort to do that. But really, fuck you, fella. You'll get your response. My response will be to humiliate your hero. How's that? Or to at least point out how he's boring, uninteresting, and his physics is superficial. So get what you deserve, shithead. You know, I mean, really, if my videos were just overtly insulting other physicists, and that's all that was in the videos, fine. these comments might mean something, but that's not what the video was. The video is an explanation, detailed, drawings, all this bullshit. No insults, just talking about what I suggest the physics says. It's just so fucking stupid and rude. All right, anyway. So then John Gray just says something, what the fuck? 5 words. 6. The electron is an electric monopole. Now, okay, so electricity, unlike charge, where there's a positive and a negative, electricity, as I pointed out, sort of is a linear thing. You can go from like some kind of 0 number to some sort of big number. And if there's a thing called a ground, that's the average of junk that's sitting around. Okay, so whatever the junk that's laying around, whatever that average is, that becomes your neutral, your ground. And then you can have less pressure. You can have an atom with less pressure than that, or you can have an atom with more pressure. Not really the same as magnetism in any way. It's pressure, as just pointed out. It's pressure, as voltage indicates. There's no pressure inside of a magnet. There's no, just not an applicable comparison. And polarizing, saying that because there's a plus charge and a minus charge, we're going to call those poles like a magnet. Well, they're not poles like a magnet. Anyway, sorry, just gibberish to me. There is no electric dipole. So, so there's no electric polarized electro. I don't even know what to call it. There's no correlate magnet to electrode or something, some kind of electrode. I mean, if I put an electron and a proton near each other, I don't create some kind of electrode thing. I create a magnet. It's just, dipole. So how can there be an electric monopole? So I'm just pointing out, I think that's just your assertion, and it doesn't make any logical sense to me. Electrons and protons make magnetism. Okay, that's the only field that exists. The only way the outside world is affected, all right, in this force equation, obviously, if you're a listener to my videos, the only force going in is this gravity stuff. The only field you can create is a field of the gravity stuff. So if you polarize the gravity stuff, that is, you filter it and make all the red stuff go one way and all the black stuff go another way, well, now you've changed the field. So now you've created a field of magnetism. But there's no field of electricity. There's no more gravity left over to be the gravity can't be electrified. It can just do the magnetic thing. And the magnetic thing can cause electricity to flow through a wire, a conductor. But there's no field of electricity. All right. Let's see, electricity. Electric is an event, not a thing. And magnetic, in a sense, is an event, not a thing, in the sense that the event is the filtering of the energy. But at least it has something that actually is getting filtered. Again, electricity is not a field. It doesn't create an emission. It's the movement of pressure through a conductor. Without the conductor, there is no electric. And in a sense, you can sort of understand that in all the high voltage things, are basically burning the poles. Okay, they're burning pieces off of them. The sun, for example. See, the electric universe, as a gross analogy or metaphor, you could argue that light is a kind of electricity because it's a kind of pressure that's pushing stuff. So it pushes little bits of the sun, the radiation coming off the sun pushes little bits. And then they go across our atmosphere and create the northern lights and do all this other stuff. Those are all things being pushed. There's no field that they're moving through. They have to be constantly pushed. And if you turn the voltage off, that is, you turn the sun's radiation off, they stop moving. That's how electrons and protons work. They don't keep moving. They don't fly somewhere. You can't. If they would make the gun, as a practical fact, they would make a gun, an electron gun, that actually shot electrons at people and killed them, if they could do it. But they can't do it because they have to provide constant energy to get those electrons to move, and they can't provide it. They can't produce enough pressure to make it, because the electrons have to plow through the atmosphere. Just can't do it. Anyway, yeah. So, and then he says a battery is an electric dipole and a hydrogen atom too. So he's saying they're somehow innately being electrical. And I'd argue they're obviously not if they're not exchanging pressure. So a single atom can't be electrical beside the fact that you either can have it under high pressure or low pressure. So the atom itself can be a high pressure atom or a low pressure atom, but it can't do electrical. It's just wrong. It's a perversion of the words. So then the little weasel, Mayul CS, chimes in with a Wikipedia link to electric dipole moment, which again is not a real thing. It's just a theoretical idea about compressing protons and electrons and their distance from each other, which again is magnetism. It's not an electric dipole moment. It's a dipole moment, period. There is no electric. And so then he recites this definition: electric monopole, N for noun. A single electric point charge, which is charge, which isn't electricity. So again, they don't understand that the charge, the pressure, isn't the movement of pressure. And everything about this always connects this idea that the electron has to be moving for it to create a magnetic field, that the movement is critical. Well, yes, there's no automatic movement in the charge. The charge has to move through a conductor, not a field. There's no field it moves through. It has to move through a conductor. It has to move through, it has to be passed from an atom to an atom to an atom. Okay. Such as an electron or positron. So again, this is such a joke because this positron is just another made up theoretical thing, speculation based on how fast protons plow through a piece of lead. And if it goes through too fast, they say it's a positron. That's all. That's all they got. They got little ghostly, rip patterns through some atoms, and they speculate on it must be something else when there could be lots of explanations. These are the same people who give photons a million properties because of all the way they bend. And as soon as they see a proton bend the wrong way, they turn into a new particle. I mean, it's like me saying that the photon that goes left or the photon that goes right, I'll call them a whole new thing. Bullshit. In which all the electric field lines, so again, the electric field lines are completely made up. There's no such thing. It has to do with some ideal circumstance where you put a charge in a perfect space with no other charges, blah, blah, blah. The field lines don't really exist as anything. They're just illustrating where the electricity will go if you put a conductor in. So that's all it's saying. If we put two charges in a perfectly even conductor, which way will the electricity go? It's a diagram of not a reality. It's a contrivance. It's just nonsense. There are no electric field lines. There's just a description of what will happen in different conductors when you put two charges in them. Yeah, there's no field. There's just the behavior. And the behavior doesn't need the external environment besides the fact that, again, it's going to be high pressure to low pressure, and it's going to need a path, and it's going to travel that path. They can't diagram a lightning bolt ahead of time. They can't predict any of this stuff because there's no field. The lightning's going to go through an atmosphere, not a field. All right, point towards inwards for a net negative electric charge. And duh, I've already gone over that one. The charge is based on the structure of the atom, the net charge, and what distance you are from it. So again, how does that have anything to do with anything electric? The fact that electrons are charged, their charge is essentially a magnetic component. It's their capacity to reflect energy of a certain kind, electron energy versus proton energy. But that's all they have. Charge is a magnetic phenomenon. Electric is, again, an atomic phenomenon, not an elemental phenomenon. It's what atoms do. It's not what electrons do. Are a way for a net positive electric charge. So again, just to again use the word electric charge to describe the magnetic moment, plus to think that charge is anything other than an identification of its magnetic potential, not its electric potential. And it's only potential. And as I pointed out clearly, you can logically understand that if you condense or pressurize negative charges, that is, put a bunch of them closer together, that they'll have more magnetic capacity. All right, so I say, what is an electric field line? Because it's obviously not something in the real world. It's just an arbitrary approximation of where the forces will be in an ideal universe that has nothing to do with reality. Yeah. And then the John Gray comes back with a Michael Van Briesen calculation of the dipole moment, which is the magnetic dipole moment. Because there is no electric dipole moment. There's no such thing as an electric dipole moment. There's no, it's just nonsense. There's a magnetic one. And as I pointed out, magnetic obviously can change the pressure inside of atoms. It can make them into little magnets. Oh, man. And as it does that, it moves the electron, which creates the pressure in the atom, the voltage. All right, so I guess I just have to go over this again. And to do so, I have to turn the other camera on. I can't do both cameras anymore, which is irritating as fuck. Right, whatever. All right, where the hell is the camera? It must be one of these little dopey things. That ain't it. That ain't it. It was one of these. That ain't it. Come on. Fucking retarded. I need the settings window, please. Yeah, it's, you know, my stupid, there it is. Okay, switch the camera. So I turn this camera off. Turn the other camera on. Hopefully this will work. There we go, it worked. Okay. Suppose we can get rid of some of this crap. And this crap. And this crap. And this crap. Yeah, that's where I have to get into the temp files to get rid of those from the other program. Oh, great, getting close. All right, so that should be enough. I don't need you anymore, right? Well, the buttons are in the wrong place. Yes, now I can just make this bigger. Yeah. And, all right, so you just have to live without me, which is, you'll probably all survive doing that. That's working. All right. So as pointed out, the atoms are made inside of the high-pressure suns. The high-pressure suns are made by the gravity force. So there's this simple force out there surrounding every single thing and pushing constantly on everything. And it has two components. The electron component, Jesus, I don't have enough room here, and the proton component. So there's electron force and there's proton force. And just imagine that's a circle, and it's coming from all directions, and it's pushing everything. Big things, little things, everything is in this field of force in a sense. Now, when you get deep inside of a sun, for example, that force is being converted, all right, from very simple photon kind of pressure. So think of them as photons hitting the surface, and the photons push the big things, okay? And the big things push into the other big things, and they push in because they're all also irradiating a force. So as much force that comes in, everything reaches a pressure equilibrium. Once they have a pressure equilibrium, as much pressure that goes in comes back out. So they're all excreting a pressure. And the point is they can excrete the pressure in a way where they have converted it from being random, like everything just comes out anywhere, red, brown, red, brown, red, brown, to, yes, the red bits will come out one side and the dark bits will come out the other side in a higher percentage. There's still going to be random in there, lots of noise and all that stuff, but by percentage, more of the red force will come out one end and more of the brown force will come out the other end. And anyway, so atoms, when you say you got an electron and you have a proton, and I'm drawing the protons bigger because they're more massive, but they could just be 3 positrons. It could be lots of things. But it doesn't really matter. The point is these things are doing the conversion in the sense that they get hit and they reflect. So if you hit this brown thing with brown force, the brown force will reflect back. And if you hit it with the red force will not be reflected, so it won't be seen this way. There won't be any red force coming back because it's going to go out this way. So that's the segregation. That's what causes the ability to change the environment and make it look different, to cause it to become a magnetic field. You throw random stuff at these two things, and what's going to happen is the red bits are going to bounce back on this side, and the black bits are going to bounce back on this side. And this is going to happen to the brown bits here, you see? So the red bits are going to tend to go this way. The brown bits are going to tend to go down this way. And if you're an observer over here, you're clearly going to see a distinction where there's going to be more brown here and more red at the below, but it's the clearest distinction is going to be created by these perpendiculars, which, will create a different environment and segregate the force, and that's magnetism. So that's the field being created. The field is the force reflected. All right. So voltage is, as I explained, electricity is being caused by a similar phenomenon. So if I put one of these magnets, okay, something that has a bunch of these in the same pattern. All right, so you have the magnet. Again, I don't want to have to re-illustrate that, because you really should have gotten that part by now. That a big magnet is made of a bunch of little magnets, that they're all lining up, red, brown. All the atoms are tending to line up with a bias. More electrons pointing one way, more protons exposed the other way. And I bring that towards a piece of certain kind of metals or certain kinds of conductors, materials. What will happen is this effect, in the sense that there's a bunch of a radiation of a particular kind coming at it, will mean that the repulsive thing will happen. And if this is your proton, more proton forces being irradiated here and more electron forces hitting down here. Well, the electrons here are going to tend to be pushed into the material. You can sort of get that. there's going to be more impacts with the electrons. The electrons aren't going to like that. So they're going to start biasing down into the material. And the protons are going to be doing the same thing over here. They're going to be biasing into the material. And the protons are going to be doing exactly the opposite. The electrons in this end will be doing exactly the opposite. They'll be saying, this is a non-pressure force. I'm not getting hit. It's free. So they're going to be moving towards. So this surface is going to become electron heavy, and this surface is going to become proton heavy. Protons pointing that way. So it creates a magnet. It magnetizes the conductor. But by doing it, like I said, it's changing the pressure of these atoms by forcing them to turn and bend. And their pressure is basically in the form of force. So the voltage in this wire would be in the same direction as the magnetism. That is, the pressurized end would be the end where you push the electrons in. So that would be the high voltage. In terms of, it would be the negative, okay, because they've mislabeled. It would be the high voltage. So I guess there's like greater than, voltage is the minus voltage. But anyway, and this would be the less pressurized on the other side, the one where the electrons are being pulled out, which is stretching them. Now, there's little simple things you could argue that when this causes electric flow, the pressure exchange will take place across the surface of the wire before it goes inside of the wire. So because the surface atoms are the most easily moved. Pressure is most easily pushed through them. But the more you expose this thing, the more atoms are involved, the deeper it goes into the conductor, and the more current is going to be created. But anything that happens that's electrical, right, is just going to be these atoms exchanging their pressure. That is, so another way to think about it is with the heat analogy. So you can sort of understand, let's see if we can have a good, well, I'll just draw an atom as a traditional atom. We'll just put a few electrons around it and just say, these are the atoms. And let's, just to give them a membrane, we'll just put a circle around it. And so that's an atom. And so we understand there's a concept that the atoms are in a condition of being at a certain thermal temperature. And the thermal temperature is understood as being how much stuff is moving between these atoms, and how much the atoms themselves are moving. So if there's little bits bouncing around, plus the atoms already have some momentum, that is, they already have some velocity, then that will dictate how much heat this system has. And I can remove heat in two ways. I can remove the little bits that are pushing, and then I can slow down the atoms. Actually, I can try to retard their velocity. Kind of hard to do, but let's say you can. And cool the substance. But as we kind of know that you can't really stop all the jitter, all the vibrating that goes on. But anyway, so that would be the heat. But the pressure is inside the atom. So the point is when the magnetism pushes the electrons, or when you pass, especially when you pass current through an atom, but in the more direct sense, what you're just creating is atoms that have actually more pressure. That is, there's more, you've compressed electrons into each other. So electrons that were this far apart, you've made into electrons that are this far apart. And so these are under a higher pressure. These are closer, so there's more impacts. So when two atoms actually come close to each other or hit, the electrons are the things that are going to be communicating with each other. And basically they're going to, this set of electron pressure is basically going to communicate with, say, this electron. It will be part of it for a moment, And what will happen is the high pressure here will be exchanged with the low pressure here, and both of them will be pressurized to some pressure that's equal. They'll neutralize the difference between them. And that's the process of electricity. So when you say electricity is happening, you're basically just saying that high pressure electrons that are too close together, are being allowed to separate. They become further apart from each other by pushing some electrons that are far apart closer together. So you have electrons on the high pressure end that are close, and you have electrons on the low pressure end that are far, and all you're really doing is just migrating a few electrons to equalize that pressure. You're migrating the space between them. So you're just saying that this set of electrons says, I am free now to move out. And the price of that is that these ones that were far apart move in a little. That's the price. So when this moves this way, it just changes the distance between these two now. So it just equalized. So there was this. Oh, camera's not. Yeah. Shit. Shit. The point is the distance. These are the electrons on the high pressure end. And the low pressure end, the electrons are this far apart. And so all you're really doing is just kind of saying, let's increase this distance and move this electron here, and we'll decrease. The price will be is that this electron will be moved to here, and this one will be eliminated. So now they're both equal in terms of their pressure. So by contact, you're just changing the distances between the electrons, therefore balancing the pressure. More importantly, reducing the high pressure. That's what needs to be. That's the push. Again, just follow the push, and you can explain anything because it's all push. Nothing's getting pulled. Let's see. I really need to say anything more. So, but there's no examples of a electric field that pre-exists, that's out there, that's sensing anything, that's changing in some way, this pre-existing field of something. If you want to move something electrically, you have to push it, and you have to create a conductor for it to travel through. So like I said, all the plasmas you ever see in the vacuums and all that, those are all created by taking atoms from the cathode and melting them, vaporizing them into the space, and creating a bunch of atoms that can now pass on pressure. But that's all it is. It's a bunch of pressurized atoms now that you've created in space because the pressure is pushing stuff out. And as soon as you give it a place to go, you can sort of understand, as soon as you create any kind of pathway that tends to allow the electrons to separate, they can't separate into just space without without the atoms being destroyed. So you have to have a really high voltage, and you destroy the atoms, then they can fly into space. And as they're flying into space, as soon as you create a ground that they can travel through, I mean a route they can travel through easily, that's where they're going to end up going, just because they're all under the pressure. And as soon as you have something that touches that high pressure and says, yes, send more, send more, send more, in the sense of send more jitter, send more depressurization, because I can handle it. So the more of a conductor you put near a ventograph, the more of the pressure of the ventograph is going to go through that conductor, because it's seeking low pressure, in a sense, seeking in the sense that it's always ready. And so as soon as you give it any opportunity to leak out, it'll leak out. It's just looking for a hose. But that's all there is. There has to be the hose. You have to make a pathway. There is no electric field. There's no field of something that electrifies There's no field that perturbates. You have to push material to allow the electrons to pass on their pressure. You have to depressurize electrons by creating a trail of electrons through which the depressurization can take place. Only an electron can depressurize an electron, so to speak. You know, only an atomic electron. That's the only way the electron gets depressurized. And the only way, again, if you're going to shoot electrons with a cathode ray tube or something, you're really ripping pieces off the tube, and you're constantly pushing them. You're sending a constant stream of photonic radiation to push the electron. And as soon as you stop pushing, the electron stops moving. Yeah, I probably shouldn't have to beat this to death. So there's a huge difference between the idea of voltage differentials and the absolute difference between the fundamental difference. I mean, charge is a fundamental property, elemental. Charge is an elemental property. Electricity is a emergent phenomenon. The elemental function is charge, and the elemental byproduct of charge is magnetism. The charge identifies the magnetic monopoles. I don't see how that can be disputed. It's that's the truth of it. That's how this thing works. You can play with the words and break the meaning of the words, but those are the only two real poles, are the poles of charge, and charge isn't electricity. Electricity is a consequence of when you shove a bunch of charges next to each other that are repulsive and create high pressure. And then the pressure has to move to low pressure. That isn't what magnetism is doing. Magnetism is segregating the force, all right? It's not pressurizing the force. But clearly, magnets pressurize the atoms by moving the monopoles. By moving the charges, you create pressure changes in the atoms. Yeah, probably enough. I think, yeah, so maybe I can go off and do something else. I have to do this the whole video. Yeah. All right. Change the camera again. I don't remember where the damn camera software is. Yeah, I just so the computer has this broken config thing. So apparently, when it configured, it configured the wrong way, and now I can't see my bottom bar. Well, always something. All right, so we'll switch back to the Meet camera, and it was. Wow, we got that one right. Pretty cool. Yay for our side. All right, something went right. Oh, jeez, come on, smaller. We don't need that much of me. Don't need this. All right, mushroom. I trust a mushroom. Would you like to participate in a physics conference this Christmas? Well, I'm not a mobile type person, so, and I'd have to know what the conference was like, you know. Are you all going to be wearing tin foil hats with, you know, tinsel hats? I could invite you to talk. There will be many people. Yes, well, I'm sort of one of these modern humans that sort of does it on the internet. You know, this really works very well. You don't have to waste money traveling somewhere, and you know, you don't have to deal with all the stupid people and watch stuff you don't want to watch, and you don't have to sit through anything or take cabs or do any of that kind of crap. So frankly, I just think doing it the old archaic way is kind of retarded. Are you interested in an anatomy? Obviously interested in anything that has something to do with understanding the world we exist in. So, and yes, certain parts of my anatomy I'm terribly interested in. Incredibly interested. All right, so we probably don't need this no more, neither. But we have to leave something up, I suppose. Um, so yes, but yeah, I have to play the video, right? That's what I'm going to go do. Play some video. All right. Subscriptions, and I think it's here. Video conference, the ancient technology. Oh, those were just terrible. The whatever CNPS guys. Oh, talking all this wacky shit about their ethers. All right, physics spring. That ain't right. That's not what I'm looking for. I have the Shinkar guy somewhere here. Earth's atmosphere. No, that ain't right either. This is very strange. It should be right after the subscriptions, which is here. It should be here. I must have broken something somewhere. Let's see what this is. Optics. No, that ain't right. Maybe it's at this other end. Could be. Let's see. Alan something or other. Fuck him. Class speaker meeting. There he is. Okay. Oh, so yeah, so he did this. So this is the guy from Yale. I won't bother playing this. It's only 7 minutes and it's not really on physics. But it was kind of funny because he was talking about the fact that he did do these, you know, he was invited to videotape his lectures and blah, 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 blah. And he did a few years ago. And those are the ones I saw. And so this is some dinner where I guess they, whatever, the different people talked. Well, anyway, so he decided to talk about the idea of this free courseware and how he didn't see it as a threat. You know, so somebody had pointed out to him, you know, you're basically making yourself extinct by doing these videos because eventually universities aren't going to bother having professors. They'll just have you watch the videos and they'll have people do the coursework. You know, they'll hire, you know, cheap physicists. They won't bother with the expensive kind. And so, the phone kill itself. Anyway, yeah. So they won't pay professors all this money. Blah, blah, blah. So I made this argument that would be the ideal universe, really, right? I mean, we just do it all by video. We all, you know, we turn education into something you pay $100 for. Makes perfect sense. It'd be great if we had videos of Einstein. It'd be a fantastic resource. So anyway, but it's just kind of funny because he was trying to convince himself that somehow that's not true. It was just so, it was such a lame argument that, and then he went and used Big Bird as an example of failure. And it's such a joke because obviously it was a huge success. It's just that the Teachers Association wouldn't allow Sesame Street to use the same vehicle to do the next grade and the next grade and the next grade and the next grade. They wouldn't really allow the free medium to do that. I mean, fucking A. It's always some kind of horse shit. What the fuck? Some of these people just can't leave you alone. Yeah, just people can't get along without me. Like some sort of advice line or something. Well, anyway, it was just such a stupid argument because clearly this medium works. Clearly, it's a threat. It's just funny. Obviously, I think we ought to allow the threat to be realized because we're obviously just wasting money on performance art. Just stupid. Let's have people redo the play all over again. Let's not videotape it. It's like not making a movie or something, right? It's like somebody writes a movie, and instead of ever making a movie of the movie, you just perform the movie over and over and over again. Like everybody reads their scripts, and you have actors, and in every theater, just retarded. Of course, you just copy it. Damn. Let's see. Body. This isn't about bodies, idiot. But anyway. Let's see. The upper and lower body are versions of one another. All right, we're almost done. Another second of this. For every muscle, the lower body, there exists one in the upper body. Oh, you're just too fucking stupid. Yin yang crap. I'm just so sick of this. It's like the whole anti-particle crap. It's just such a lie. I mean, this is all just such crap. Oh, fuck. Incredibly stupid. Why don't you do numerology next? And then you can do voodoo. Oh, fucking idiot. Can't hear you. Well, you can hear me now, I think, fuckhead. Can you hear me now? Yeah, I was on the phone. That's why you can't hear me. I was on the phone. What do you think about LGBT? Who cares? I don't know what that means. In physics, did you know Isaac Newton was bisexual? Isaac Newton was bizarro. Okay, the man lived 1 mile from the ocean and never went to the ocean. I mean, I'm an agoraphobic, so I understand that. But that's bizarre, right? You're not on the fucking subject, shithead. I really don't give a shit about this crap, okay? Make physics arguments or don't comment. Oh, damn. Just damn. I mean, these people just can't get the program at all. So this was some interview he did on some Chinese program. So I figure I'll play this in honor of the rude, obnoxious putz who thumbed it up. Not very popular, obviously. 50 to thumbs up. Hasn't been watched much. So just more evidence that nobody gives a shit about physics much or physicists much, except for watching silly shows. So we'll jump ahead to where he gets to the interviewing part. And hear that.
Came to India to exchange ideas on education.
Wow.
So I'm coming 1,000 years later to do the same thing.
Kind of like a dream country for you this time.
Yes, everything is amazing for me because I've imagined it and now I can actually see it. And I've been traveling for 2 days since I came, saw all the big attractions, sometimes on my own. I was telling you the things I like. Taxis in Beijing are the best.
Okay, so he's doing like a pro-China video. A physicist visits China and says, okay, commie good. But anyway, they're not really communists, though.
Why the best?
Because you don't have to argue with them. You don't have to bargain with them. Then it's also quite cheap.
Reasonable price.
Yeah, and I like the bicycle system you have. You can pick up a bike and you ride somewhere, you drop it off somewhere else.
Yeah.
I like that system.
Very convenient.
Except you're sitting on a bicycle that who knows who sat on. I want lots of sanitary things on that bicycle. Or no seats. Give me a bicycle with no seats on it or something. Ugh.
To ride a bicycle.
Yes, and people are very helpful because my wife and I got lost in Tsinghua campus. We did not even know where we lived. And yet, some young guy walked with us for 20 minutes and finally figured out where I lived and took us there. That's my example of Chinese hospitality.
I see. Anyway, welcome to China. You know, we are also quite cute.
I'm sure he didn't go walking the poor people's streets. Like every place looks great, you know, as long as you don't scratch it or kick it or smell too, you know, do that too hard.
It's about your teaching experience and your teaching at Yale. Yale has been one of the most prestigious universities in the world. It's like a dream place many students love to go to.
Yeah, no, it's just a place for a bunch of the crappy disease-covered spawn of the mega rich send their kid to get a fake degree. Yeah.
Tell us what it's like teaching, working at Yale.
Yes. So I've been at Yale for 40 years now.
40 years?
Yes. I came there in my late 20s. Then I never left. And I love the place. If you ask what I like the students at Yale. Mm-hmm. They're very broad, interested in many different things. Mm-hmm. And
yes, and they tip you well.
I learn from them just as I teach them. Very curious. Mm-hmm. And Yale as a university is very supportive of teaching. It's not true in all the places. Some places think teaching is a headache. Mm-hmm. Yale thinks teaching is a duty and a privilege. Mm-hmm. And if you're very famous and you say, I'm famous, I don't want to teach, they don't accept that. They say if you're famous, that's even more reason for you to be in the classroom than other people. So everybody at Yale has to teach, and I like to teach. And when I first came to Yale, I was writing my first book on quantum mechanics.
Yeah, I wonder how many of those you sold. Yeah, but whatever. Fine. La 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 la. Yeah. So far, so boring. All right.
And a lot of places would say, don't write a book when you're young. It's time to make your reputation in research. But they encouraged me to write the book. They, in fact, finance the cost of typing up the book and producing it. And they value teaching. If you're a good teacher, the chairman of the department knows you're a good teacher. Mm-hmm. Promotions are based to some extent on teaching. I like that.
Yeah, well, see, this guy really doesn't have a clue that what Yale wants is for its teachers to become prestigious and to be substantial and to be winners, winning team kind of thing. Just like sports or anything else, because it just makes Yale able to charge more money. So, I mean, get real. That's why it encourages you to write or to do anything you can. It probably tell you to, well, can you walk around in the traffic a lot and get hit by a car, and then you'll be in the newspaper, and you'll up your
aspect of Yale. So I've always enjoyed teaching, and I'm glad to be in a place that values teaching.
Very good, very good. We all know that also the motto of Yale is, it is translated to English, it's called light and truth, is that right?
Yes.
Yeah. Can you tell us how that is applied here?
You caught me with surprise. I haven't thought about how it's really applied. We read the motto. Mm-hmm. I would say every educational institution has to be about light and about truth.
So they're talking about light and truth in metaphysical ways. La, 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 la.
Light, so you don't hide from anything, and truth, so you say it like it is. It's particularly important for academic people to have that freedom. This system of tenure in America, when you give a job, call it tenure to a professor, they cannot fire you for saying anything. Mm-hmm. You may say something that's popular with your university, with the government, with your colleagues, it doesn't matter. Mm-hmm. You are free to say it. And that's part of light and truth.
No, that's part of an unrealistic cheat, where you don't have accountability like everybody else. It's somebody you can be a Klan member and, oh yeah, you can't touch me. Oh, fuck you. We're going to touch you.
And the university does respect that freedom. I talk now, I tell you whatever I want. I'm not worried if President of Yale is listening to me. In my case, I'm not worried because I only nice things to say.
Yeah, which is also just bullshit because there's two sides to this coin. There's the side where, they can't fire me. But there's also the side, well, if I make enemies, then my advancement is dead and my financial opportunities are killed. So let's not pretend that isn't what's ruling people anyway. So the this idea that I have academic freedom. Well, no, you don't really if you expect to go anywhere. Unless you expect to go to another college, you don't have it.
About Yale. Even if I didn't, I wouldn't worry about it. That's the aspect of life at Yale and many universities I really like.
Also the truth, as long as you are.
Yeah, as long as you made some, if you make some speeches about the spawn of the rich, I'm sure the Yaleys aren't going to like you much. So why don't you talk about how the institution is really financed, that it has really nothing to do with the public. It's an elitist ivory tower, period.
When you teach, you think everything you say is true. You don't have to lie in physics, but you can be wrong in physics.
It's just alumni, free ride for the alumni. As long as you give us some money when you die.
What if a student points out in the lecture that what you said is wrong? What are you going to do? You can tell them to be quiet, or you can think about it and say, you know what, you're right. There you're teaching them something more than physics. You're teaching them that the number one principle is academic honesty and integrity. And if I'm not...
So again, more just crap. I mean, you can't talk about this integrity shit and all the rest of it when your whole physics pretends this is the most, predictive, fantastically accurate, whatever it is, regime ever invented by mankind. Quantum mechanics has done everything and invented everything. The wooden spoon, the everything. No, it didn't. I mean, it's all part of this propaganda. Again, the Young experiment, a completely unremarkable experiment. This guy was like blowing all over it, like this was the moment in history. When no, Newton had already seen every one of these stupid effects. He'd already done the hair in the light thing. He'd already done the two-slit experiment.
Right, I should be willing to accept that. And I try to show that even in these online lectures. Once in a while, you'll find I'm making a mistake. And the students point it out, and I make a big fuss over that because I want them to feel that's good. I want them to feel. Sometimes they try to catch me.
Yeah, these are just stupid mistakes, right? They don't really argue any physics in any of his lectures ever. All they do is you forgot to square that thing in the in that brackety thing. Oh, typos. That's all you can point out are typos. You can't point out that. Aren't you really just religious people? You have a tiny bit of evidence and you just speculate and create whole theories about dark matter and big bangs and positrons and anti-particle annihilations, and you just make all that shit up out of a frickin' grain of sand.
Right, and I tell them, sorry, try again. They always want to catch me when I'm wrong, and that's a good thing. That's part of truth in life.
Very good, very good. So you would like to encourage students to
Yes.
challenge
Propaganda, just talk very nice and friendly, and the propaganda goes right down their little throats, down their neck, and, up their neck into their brain. So, yeah, sell it, baby.
You want to be challenged because, look, I've been teaching for 40 years. After a while, the subject gets boring. The same Newton's laws, the same laws of quantum mechanics. What makes it interesting is the students are different every year. They have different questions.
Yeah, but they're idiots. So why don't you take on somebody a little more advanced than your students? Somebody a little less intimidated.
And sometimes you say something for the 35th time that you think you know, and some student points out something that you never thought about. So that's why class participation is very, very important. You have to encourage students to take part in the class.
I see. A very good approach to encourage students to answer questions.
So obviously no student pointed out that, well, why was Young remarkable when Newton already did all those experiments? No student asked you the question, huh? No student asked you the question, well, if Huygens makes 2 waves with a single slit, why doesn't it make 4 waves with a double slit?
Or you can look at the subject from different perspectives.
Yeah.
You never know, maybe they can help you extend the subject.
Yeah.
If you discover new
Yes, you're absolutely right. You tell them that your job is not done when you learn something.
Yeah.
Because one day you have to contribute to knowledge. Otherwise, we'll be learning the same thing, right? But each year.
Yeah, well, so frankly, that's sort of a dilemma. I mean, there is a time when you've said everything there is to say about how to ride a bicycle, for example. And there's nothing else you can do except add pantomime or something. You can you can say it with your hands doing funny things, but you're not going to say anything. It's a simple subject. It's done. It's not that complicated.
There's new stuff to learn. Where do you think it comes from?
Exactly. You want to keep upgrading yourself.
You have to feel that it is a work in progress. It should be constantly modified, not by somebody else, but by you, the guy in the classroom or girl in the classroom.
Yes, make up some stuff like everybody else. Yeah, just close your eyes and say, well, instead of 3 bears, why don't we have 3 blind mice, and everybody will have sympathy, and it'll be a much more fun story.
That's also why, before you can, your name actually preceded you. Your Yale Open courses that was showing on our platform, that is online courses. Actually, there are 2 of them. One is the Fundamentals of Physics 1, and the other one is Fundamentals of Physics 2. Yeah. And I checked the data the other day. They have accumulated millions of video views. That shows how popular you are and how popular your course is. And also, without a doubt, your course.
Nah, so us Chinese, we know how to steal video because video, good idea, steal the video. Oh, it's not stealing, right? You give away free. Oh, very good. Why not?
One of the most popular international courses on the platform.
Thank you. I think I'm grateful to Yale for giving me the opportunity to take those courses.
Yeah, tell us, how did this happen? How did this Yale Open course happen?
Well, first of all, the fact that I was even teaching that course is not in the normal course of events because I was normally teaching advanced courses. Yeah. But when I became the chairman, I did not have to teach. So I didn't like that. I like to teach. So I was waiting for some excuse to get into the classroom.
You love teaching?
Yes. So one of my colleagues who was supposed to teach introductory physics.
So that's why he was, because his lectures, to tell you the truth, they're so dry that, it's all math and it's really uninteresting and he draws terrible. So, yeah, I argue that he's not a Walter Lewin.
He fell ill in the summer and the classes are beginning in a couple of months in the fall. There was no one else to take his place, so I said, I will do it. Then I started teaching the course, and I found that I enjoyed it a lot more than I expected. So I taught it a few times. The students liked it, and that's when our dean, Peter Salovey, who's now our president, he said, we would like to record it as part of our Yale Online courses. It was the first science course they did, but they were not sure there's any interest in watching a science video. Well, so
it didn't occur to anybody until then. I mean, it's just amazing when you think they couldn't figure out how to do this. Like as soon as Edison invented the talking machine, they should have thought of this. I mean, no, it is kind of amazing.
They realize that's not true. There's a lot of interest in science videos because science is universal. You can talk about the electron in New Haven and you can understand in Beijing because it's the same electron. Yeah. So physics is universal appeal. So that's when they decided after some time to record the second part of the course.
Well, he's not even getting the appeal part. It's a commodity. Education is a commodity, and you're giving away the commodity for free. So that's, obviously there's going to be interest by people who can't afford your stupid Yale prices.
So the success of the first one.
Yeah, they realized that it's okay to put a video out there in physics. And it's been very helpful for Yale because people know we are strong in science. People know that we care about teaching. We want.
No, it's not really going to be my impression. I'm just saying if they sample the different institutions, Yale comes off dry and boring. So I'm just saying.
People not like Yale. You said it's a very coveted institution, right? Every student wants to go to a good institution, but every good institution wants a good student. It goes in both ways, and this is our way of letting people know. If you come to Yale, this is what your experience will be like.
It's really satisfying to be honest. I think lots of them were really, before that Yale Open courses, we always were wondering what was it like sitting in a classroom Yale learning courses.
Right. In fact, they kept the atmosphere as natural as possible. There was no special studio. It's a regular classroom, regular blackboard, regular mistakes made by the prof, regular corrections, same jokes, same laughter. Everything was recorded on tape. That is really, you're right, there is no real difference between being in the classroom.
Yes, he does tell jokes. Humorous, but not worth the price of admission.
And watching the video. And I'm glad that a place like Yale is willing to offer this to the whole world for free. It doesn't cost us anything.
Yes, everybody else is doing it, and so that's why Yale did it. Okay, just tell the truth.
They're always sure the students will come to Yale anyway. Why not share it? And when I was a young man in India, I was trying to learn physics on my own because I was an engineering student who wanted to study physics. And I didn't know where to learn from. And if such a course had been available at the time, it would have been very helpful to me. But now I know that kids all over the world learn from that. Not only kids, housewives.
Housewives as well.
They say, look, I wanted to do physics, but I got married and kids had no time. But now when my kids are in school, I want to go back and learn physics. So I'm learning from.
Yeah, I'm sure millions of views are from women. I'm sure like a big giant percentage of the million views is women, housewives learning physics. Huge percentage.
This course. So we don't know who will rise. It's not always some student trying to get into college. It could be a retired doctor who always likes physics and wants to learn.
It's like anyone who's interested in physics.
Yes, anyone. And anyone can now see how it's all made out of crap. It's just a religion. It's, 50-50 maybe. 50% hard science and 50% just made up crap.
Like, there's always a place where we
Yeah.
continue with the interest.
But you got to do the work. You cannot just learn all the fancy words. I tell them the words mean nothing. They depend on the language they're using. Only ideas are same. So I tell them, by all means, take the course, but just don't learn the fancy terminology. Try to understand.
There's no understanding. No, it's just memorizing formulas and period. And there's just little else that you teach. The concept of how this thing works, you just use words like an electric field. Here's the lines. Man, there's no field. There's no energy in that field. It doesn't exist. It's just made up. You just change the way the field looks when you change the physical matter in it.
What's behind it?
What's behind the laws of physics?
Yes.
And help them with daily lives.
Yeah. Well, I'm not that helpful with daily life. I'm a theoretical physicist, and if you want something to be repaired, you shouldn't come to me. I'll probably break it. So I'm more interested in physics just because it's a very beautiful structure.
Oh, it's amazing. So he's a theoretical physics guy who was teaching the introductory courses, which is kind of probably not too good an idea.
Art is beautiful structure. Symphonies are beautiful. Physics as a subject to me is equally beautiful. It's beautiful because it has nothing to do with human beings, nothing to do with day-to-day politics or power struggle. It is something permanent, which is there. It's operating all the time. And we have managed to...
It's a puzzle, and he thinks they solved it. They solved it by just hammering pieces into places they don't belong. And that's all they did. Oh, we can't explain this gravity thing, too complicated, so let's just make up an invisible vacuum cleaner system that pulls everything together. Well, that doesn't really fit. Doesn't make much sense. Just hammer it. It'll fit. Time is a dimension. Just hammer it. It'll fit.
Somehow find out what the laws are. And we find the laws are written in mathematics. And mathematics is...
No, mathematics is writing the laws. It isn't that mathematics is the laws. I mean, it's just so backward. I mean, you can't even say... No, I shouldn't say that. That's stupid. It's getting it totally backwards. The math didn't make the laws. The laws created our mathematics. They're just describing the laws. And again, some of them aren't laws. They're just tendencies.
It's in some sense a human invention.
So the mathematics and the physics go together.
They go together. And if you think that you can do mathematics, you can do physics without mathematics, it won't work. It's like saying, I want to sing in the opera, but I don't want to learn any language. You cannot.
Yeah, it's just bullshit. No, you can't do physics without mathematics when all it is a model of movement, things moving. Of course you can do physics without any mathematics. It's just movement.
This is the chosen language, and you have to learn it. But once you learn it, the rewards are very high. Sometimes the mathematics will tell you.
Yeah, it's just a way of veiling the bullshit and so much bullshit that you can't see it anymore. So it doesn't matter whether it's right or wrong or close or an approximation. Because nobody can tell anymore because you've mushed it so much. You've turned everything into some obscure symbol. And you don't have any idea at all what it means or what it's there for or what its function is.
something will happen that you will never think of on your own. But it comes from simply solving the equation. The equation will tell you, besides everything you put into it, there's something else implied by these equations. If you look at that corner of the
there's just a list of the things that affect the circumstance. So you just identify the things that affect the circumstance, like the B field, the magnetic field, versus there is no electric field, versus the density of the charge versus this, and you just put all of those in, and yes, you have a formula that'll tell you what you can expect as an outcome. But it's just a mixture of variables that are real things.
sky, you will see something. You look there and you see something. For example, that's how one of the planets was discovered. They found out the planets were not moving according to the Newtonian laws. Then they figured that's got to be another planet because it's disturbing these other planets.
How to discover new things.
Yeah, then they figured out where should the new planet be to produce its effects. Then they figured out where it is and what radius it's at.
Right. And they had a model, and they found that the model indicates there has to be something happening because there's this little part that's wobbling wrong, and something must be making it wobble wrong. Not complicated, not miraculous in any way.
The point of the telescope, there it was. Now, how do you explain that? I mean, why should it have to be that way? What will you do if the planet's not there? Who are you going to complain to? But the fact is, it works. To me, the amazing thing is that
Again, this example is just, they have to go back in history to find one of these examples because, that's not what physics is doing anymore. The model is so convoluted, all they're doing is creating and inventing and finding things that don't exist and naming them things.
such a thing exists, and it works, and we found out.
Using the language of physics and
And mathematics. This is what I try to talk about in my course. It is not so much about how to compute things. It is important. If you don't want to compute, get out of physics. You should be ready to work hard, ready to compute. But to stop there is to mix some of the excitement. It's like,
Well, that's the bullshit because there was no excitement. His lectures were, like I said, he didn't do a single demonstration of anything, and barely drew useful diagrams. It was all math.
learning the notes in music. But you listen to the symphony, it's more than the notes. It's something else that you appreciate. Right? You should take some time to appreciate how amazing it is.
It's amazing.
All right. So anyway, enough of this. Maybe we'll come back to it. It's more boring than I thought it would be. It's just blah, 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 blah. So anyway, that'll be enough of a video. We'll see if there's any comments worth reading and then get out of here. Let's see. Let's go back so we can delete by blocking. Yeah, it'd be so cool. Oh, I've seen a few of this guy's intro physics lectures. Yes, well, you've seen some of them right here, because I've played some of them. Anyway, why are you so anxious? It's irrelevant. If you are gay, it doesn't matter one way or the other, but I'm not, but it doesn't matter. There is nothing wrong with coming out. Well, again, I've never touched a penis or anything. I'm not afraid of them, but I don't need to sleep with one, except my own. You may be more happy later. Look, I don't need this shit. Okay, goodbye. You can't. Obviously, it's a physics channel. You don't want to do physics. Fine, then fuck off. Oh, Christ, these people are just insufferably retarded. Get rid of that. Thank you. Thank you. Let's see what else is said here. Mushroom, you're a physicist? Yeah, well, whatever he is, he's done here. It seems like people learn physics to use it in some form of application. Yes, you have to make a living, or it's really stupid to go to school for 4 years to be homeless on the street. So you usually have to use a kind of physics. You have to become an expert at something like mass spectroscopy or some other kind of stuff. And yes, become proficient at that. You have to specialize or you will fail. Very few people get to be theoretical physicists and make a living. From my point of view, understanding for its own sake without any business application is not how colleges educate. It doesn't really matter. The bottom line is a huge portion of it has to be somehow factual and useful. So, yeah, I mean, I think they are. I think the academic physics is just full of a bunch of unnecessary crap. I mean, they might as well make people into specialists right from the beginning. They might as well not bother with theoretical physics if you're going to be doing applied physics. So they shouldn't waste the applied physicists' classroom time talking about any of this black hole, big bang, loony doopy doo whoop-de doo bullshit. I mean, you shouldn't waste an applied physicist's time learning any of this cosmology crap. Cosmology. True, but it's how a lot of real progress was made. Newton, Einstein, Faraday with his famous quote, whatever all that is. I had no idea what use their stuff would eventually be, but they enjoyed it. I don't know what that means. Blah, 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 blah. Gibber, gibberish, gibber, gibber. All right, so I'll give you 30 seconds or whatever. Somebody's got something relevant on the subject of pressure and the difference between magnetism and electricity. There is a magnetic field created in that it is filled with energy by a magnet. A magnet fills the energy field with its effect. It takes stuff that's all random and makes it unrandom. Okay, it does something. The pressure inside of an atom has no outside effect until it gets connected to another electron under pressure, another atom under pressure. Without a conductor, electricity is nothing. All right, Euler, who cares about this fucking name-dropping crap, and Raman Ramanujan too. They did math just for the beauty of the form. Yeah, well, whatever. Well, that fucking crap is. I don't see anything beautiful in convoluted integrals divided by square-rooted, frickin' secular whatever tensors. If you're a military industrial power, this doesn't sound like much useful physics conversation here. You would want certain discoveries to remain undiscoverable by any potential enemies. Again, just that door, that horse left the barn centuries ago. I mean, that's just so gone. You can't cover it up anymore. So that's just a waste of people's time. Sword making was like this in the Middle Ages. Obviously, you didn't give away your technology overtly, but obviously everybody figured it out. You're in a battle on the ocean, and they have a little square wave, and you have the modern pointy wave, sails. And guess what? Yeah, you're going to figure it out. How come their boat was able to turn into the wind and still move? How'd they do that? And they figured, they got these sails that are catching the pressure and moving a little bit sideways, and they're skidding, around the curves. Yeah, well, let's get a curvy boat. Yeah, so we can do that. Yeah, they're going to figure it out. Yeah, I mean, when they raped and pillaged, they probably didn't kill the blacksmiths, obviously. There was stuff worth capturing, taking back home with you. But we're not in the Middle Ages anymore, so really irrelevant. What, anything, people? I guess I might as well play a tiny bit more of this. We'll see if anybody has a comment on the way.
Yeah, and I feel it every time I teach. I never get tired of it. how wonderfully everything works.
Well, you just pointed out before how you do get kind of samey, and it's the same stuff over and over, and it's geez, it's not unless there's like a cute chick in the audience or something and perk you up a little bit because it's just so samey.
And every time I teach it, I derive the laws. Then this is how the equations work. Then I say, when you look at the real world, it follows this. And no matter if it's the 40th.
There's more crap, right? There's just no real world examples of where these freaking annihilation events are taking place, or the zillions of neutrinos flying through us right now. There's no real world anything for this crap, and there's not even a theoretical model that makes any sense of where these stupid things are inside the atom, where they're just hiding somewhere. I'm just hiding over here, don't pay any attention to me. I mean, it's just such garbage. It doesn't even fit in their own stupid model.
I'm still amazed.
I mean, they keep trying to find energy because they don't have any for all their effects, okay? They got no source of energy for magnetism and no source of energy for gravity. And they just keep trying to shove the energy into some hidden place so they can explain where it came from without overtly saying it's doing the thing. They're saying it's the byproduct of the gravitational force. So now somehow they're accounting for the energy existing by turning it into some new byproduct. So they're essentially almost saying, like, when the gravity goes through you, it's gravity, it's bent space. But when it comes out of you, because you're already at equilibrium, it's neutrinos.
And I feel that, and I think that's what I relate to my students.
I think sense of feel, you have a strong passion.
Yes, and that you have to communicate. A lot of people who took this course are not physics majors.
Yeah.
Some are going to medicine, some are going to chemistry, some are going into humanities. But you don't have to be an English major to appreciate Shakespeare, to understand it. Somebody, same way, you don't have to be a physicist to appreciate the structure of physics.
Well, I'm sorry, if the structure of physics is a bunch of convoluted mathematics, frankly, yeah, you gotta you gotta have some notion that all that crap leads to something like a vision or something, a picture, and you're just no good at drawing the picture, as I demonstrate. You can't even draw an accurate picture of the two-slit experiment.
And I think it's more important to explain physics to people who will not be in physics. Because one day they will work in the government and they will decide whether they get funding or not. You have to tell the other people.
Oh yeah, whatever. All that course shit is. So again, I shouldn't even play it any more of it because it's stupid. So fuck it. They're going to have government jobs and they'll remember when they were at Yale. No, none of them are going to be doing anything. 90% of the Yale graduates are going to be like all the elitists. They're going to be playing golf somewhere. Horse shit. Let's see. Head to the top secret laboratories, patent and trade secrets. Oh, so it's just conspiracy theory shit now. I mean, you're just all a bunch of nutters. Oh, they have the secret Tesla papers. Yeah. This is just pathetic. Yeah, all right. I don't know what to say. I mean, I won't block you. I guess I'll just, for the hell of it, just for the fun of it, I'll indicate my displeasure by saying, put you in a timeout. It's really not the agenda of this channel is to waste my time debunking your truther theories. You either defend conventional physics or you somehow attack my physics, but you're just wasting my time talking your little wacky conspiracy nuttery shit. I'm not denying that the military might have some knowledge about some missile technology or something, but it doesn't have knowledge of fundamental physics. Yeah. No. And certainly the companies that are employed by the military or hired by the military certainly don't have enough, there's not enough, they don't kill the employees, they don't they don't make sure that the knowledge dies with him. So it all leaks out eventually. All right, so anyway, I guess we're done. So till the next time and such. No rational commentary on the subject, unfortunately. But